Good evening, folks. In part 1, we went over the solar control of the upper atmosphere. In part 2, we went over the solar control of major climate cycles at the millennial scale and how they dwarf modern global warming. Here, in part 3, we will discuss the access the sun has to the lower atmosphere, with various ways the sun can rapidly affect the atmospheric electricity, temperature, and storms. And by rapidly affect, I mean rapid. We'll begin back where Dr. Brian Tinsley was part of a team that confirmed previously published suspicions about space weather forcing of surface pressure in the infancy of the field. They were really only able to detect this coupling at sunspot maximum. There's thousands of authors and studies in the field up to now, but let's follow Dr. Tinsley up through time. In 2012, we see the fight Svensmark started with deeper detail and observational reality of the electrical forcing on clouds. This varies based on cosmic ray modulation and short-term solar and Van Allen belt particle forcing. By 2016, the observations had driven beyond big data to recognizing the process at work in storm invigoration, both from the cloud forcing and electric invigoration. In 2017, the solar wind kiss to the global electric circuit was further evaluated, showing how the entire circuit reacts, not just the downward current coming from the ionosphere, but the upward current as well, important because the low pressure is where the storms are, and where the current in the circuit goes back up. 2018, the focus on the polar region, which had been a major part of Dr. Tinsley's other publications throughout the years. It solidified the particle forcing aspect on clouds where sunlight is less of a factor and subtle electrical modulation can more easily be seen. The follow-up study in 2019 confirmed that the effects last for at least a day, with the same location registering increases in downward current and then upward current when those systems had moved on. By the end of 2020, it seemed almost elementary how the team demonstrated the forcing of the total atmospheric column through the global electric circuit, and this is how the sun accesses the clouds, works the temperature, and the storms, and does so rapidly. Now we recall part 2, when we were discussing the ways in which the rapid solar forcing through superflares has multi-degree spike effects on temperature that come on instantly and last for weeks. We specifically saw this paper, an excellent one on demonstrating how the Carrington event and even more common solar events can have a rapid regional and even global temperature effect. Some of this is bound to be irradiance in a superflare, but also all of the particle forcing avenues would get flooded in that event. In part 1, we went over how the solar control of the upper atmosphere, its density, temperature, winds, and superrotation was pretty much complete, and just since part 1, by the way, we've seen 2 more indications that the sun controls the thermosphere. They're coming faster than a summary can manage, and we know that for many reasons, the sun affects the global electric circuit within the thermosphere across all latitudes. Now we'll see why momentarily, but first, how rapid is that rapid I mentioned? Well, one paper describes the effect and recovery periods as nearly instantaneous and within 1 minute, respectively, both of which indicate the severity of the coupling, a severity that hits various thresholds of forcing. Another team described it this year as both nearly instantaneous and with the ionospheric potential transferred at the speed of light. Take out the nearly for the instantaneous forcing identified a few months later, with the radiation belt enhancements lasting much longer than the ionospheric disequilibrium. Another word they used to describe the electric coupling here was immediate. These effects have been seen in storms, both in the winter and in the summer, including the most powerful of those storms, those in the tropics, often for the same reason that we see the lightning modulation during impactful space weather. That was from our textbook, Weatherman's Guide to the Sun, which we will dive back into here for the storm forcing focus of part 3. Following the massive solar activity in 2017 and the major hurricane activity that followed that year, papers confirming previous findings were major news in 2018 and 2019, fueled by the excitement within the field at a national science championship being awarded to Ferris Wald for showing the coronal hole control over the cyclone frequency in the world. These correlations have been well connected to the geomagnetic and geoelectric systems. The global electric circuit is where those complex coupling systems above are then distributed into the lower portions of the atmosphere through the vertical columns. Now, not every paper pegs it right. While the statistical correlations described here get a huge thumbs up, their pathway of forcing is relatively cloud-focused, without attention paid to the circuit effect on the winds and the pressure cells. Here's another one, finding of correlations all around, but their best correlation was between solar radio flux and hurricane wind speed, with a lag. Well, what happens during that lag? Only the entire process that is worth noting. The radio flux indicates enhanced particle flux is coming, which will couple with the geoelectric system and excite the global electric circuit, modulating the pressure cells and therefore the wind speed of the hurricanes. The gold medal of the last 3 years goes to Dr. Paul Prickroll, whose work on tropical storms and extreme weather of all kinds has been the forceful demonstration of late and mechanistic action of the solar wind coupling to the lower atmosphere. This undoubtedly works with the global electric circuit, as we've been discussing, but now let's come back to why the space weather impacts that circuit at all latitudes. Solar flares from sunspots often last or recur for hours or days, which juices up the ionosphere as the world turns. The solar wind enhancements last for hours as well, and pushes the Van Allen belt particles into the ionosphere and upper atmosphere. We know that the auroral excitement at the polar region sends that energy down towards the equator, and we're just using the Jupiter visual version because they don't have an Earth one, and this is much prettier than looking at that paper about equatorward traveling waves excited by the auroras. The geomagnetic system works at lower latitudes too, in addition to the poles. There is an electrojet at the equator as well, and while it's largely fed from below, this one also takes induction during solar storms, just like the northern lights. The L shells, which are the various size arcs of the planet's magnetic field, are similarly excited and work so much particle energy down through the atmosphere that radio signals can be detected from those fields at ground level. They penetrate to latitudes just touching the outer rim of the equatorial electrojet, by the way, which is probably not a coincidence. These and the global electric circuit are the method for the rapid forcing of the lower atmosphere, and they present in the most extreme examples because the forcing results appear to require certain thresholds of energy. Now, this is really not that complex at all, and I can explain it to you like raw chicken. At 0 degrees, 10 degrees, 20 degrees, 50 degrees, all the way up one by one, you get the same result. The chicken has bacteria on it. You can even try every fraction of a degree below the cook point and get the same result, but then, all of a sudden, like a magic number, the chicken changes when you hit the cook point. Its color changes, the bacteria die, and neither of those things can go back to the way they were before. Once you hit that threshold of forcing, the condition is forever changed. By the way, there isn't enough room in YouTube description boxes for all the links from this video, but the ones we didn't show in full, the citations from our book, and hint hint, these are some great ones to check out on the global electric circuit. All of those can be found at spaceweathernews.com/publications, where the full bibliography to the textbook is available for download. So folks, this is relatively powerful stuff, but if we're being honest, it's only just grazed the playing field of the big game, global warming. In Part 4, we will examine everything working towards making a warmer world right now and see why the picture is dimming for the blame on CO2 and on the temperature in the future. I'll see you in the morning. Be safe, everyone.